Okay, text 1, text 2 looks like we've got a paired passage or cross-text comparison as they call it. And we want to know that Fire's team and the authors of text 2 would most likely agree with which statement about microbes. So we want to know what would text 2 agree with about microbes in text 1, basically, or just in general, really. Okay, so text 1, microbes are tiny organisms in the soil, water, and air all around us. They thrive even in very harsh conditions. That's why Noah Fair and colleagues were surprised when soil samples they collected from an extremely cold, dry area in Antarctica didn't seem to contain any life. The finding doesn't prove that there are no microbes in that area, but the team says it does suggest that the environment severely restricts microbe survival. So microbes, they thrive in harsh conditions in soil and water and air. They're kind of everywhere, but oddly enough, and surprisingly, they use the word surprisingly, they weren't in extremely cold, dry Antarctica. Okay, so no microbes in Antarctica. Okay. Text 2. Microbes are found in virtually every environment on Earth. So it's unlikely they would be completely absent from Fire's team's study site, no matter how extreme the environment is. There were probably so few organisms in the samples that current technology couldn't detect them. So they were there, just we couldn't detect them. There were so few of them. But since a spoonful of typical soil elsewhere might contain billions of microbes, the presence of so few in the Antarctic soil samples would show how challenging the conditions are. So what's the idea? The author of text 2 would say, there probably were there, but just not many. And I'd agree that that's a result of it being challenging. So the environment restricts the survival of the microbes. The environment is challenging conditions for the microbe. That seems to be the agreed on point between two texts. So let's find the answer that matches that. Most microbes are better able to survive in environments with extremely dry conditions than with harsh. No, there's no comparison. That's our typical false comparison. There is no actual comparison in the text here between dry conditions and harsh temperatures. That's wrong. A much higher number of microbes would probably be found if another soil. No, it's not if and would have been found. Obviously, they took many samples. I doubt they needed to take another. That's not correct. C, microbes are likely difficult to detect in the soil in the Antarctica study site because they tend to be smaller than microbes found elsewhere. Oh wait, the microbes in Antarctica are smaller than the microbes elsewhere. That's just not in the text. Okay? It's going to be D. Most microbes are probably unable to withstand the soil conditions at the Antarctica study site. Yes, that's what they agree on. Antarctica severely restricts microbe survival, and it makes the conditions there are challenging for the microbes. There are less of them. D is the correct answer. Okay, text 1, text 2, we're looking at a paired passage or text comparison problem. Let's see, what do we want to compare? What would the author of text 1 say about the experiment in text 2? So we want to know what this guy here in text 1 would say about text 2. Well, let's take a look. Text 1. The idea that time moves in only one direction is instinctively understood, yet it puzzles physicists. According to the second law of thermodynamics, at a macroscopic level, some processes of heat transfer are irreversible due to the production of entropy. After a transfer, we cannot rewind time and place molecules back exactly where they were just before, just as we cannot unbreak dropped eggs. But laws of physics at a microscopic or quantum level hold that these processes should be reversible. Okay, so these things should be reversible, but they don't get reversed, basically, or can't get reversed easily. So, okay, text 2. In 2015, physicists such and such performed an experiment in which they confirmed the irreversibility of thermodynamic processes at a quantum level. So wait, it was the quantum level up here where they should be reversible. But here he performed a study that showed it's not reversible. Okay. So producing entropy by applying a rapidly oscillating magnetic field to a system of carbon-13 atoms in liquid chloroform. But the experiment does not pinpoint what causes irreversibility at the microscopic level. So it showed irreversibility, but it doesn't say anything about what caused it. So what would the author of text 1 say about text 2? That it doesn't really prove the point. There could be some weaknesses in the conclusions or shortcomings. My guess, the author 1 would definitely be surprised because author 1 thought at the quantum level, these should be reversible processes. Okay, let's take a look. A, it would suggest an interesting direction for future research were it not the case that two physicists who conclude the experiment disagree on the... No, okay. There's nothing in here about where we should go with future research. That's not it. B, it provides empirical evidence that the current understanding of an aspect of physics at a microscopic level must be incomplete. That it does, right? So this is an experiment. The empirical evidence of that experiment shows that the reversibility that should be true at a microscopic level is not true. In other words, it's incomplete. This is pretty good. I'm going to hold on to this one. Let's check C and D. It is consistent with the current understanding of physics at a microscopic level, but not at a macroscopic level. No, text 1 said a microscopic level, it would be reversible, and it wasn't reversible. So this is, the whole experiment and everything is inconsistent. D, it supports a claim about an isolated system of atoms in a laboratory. Okay, right away, atoms in a laboratory, we have no idea if that's, of course, they were probably in a laboratory. But that claim should be extrapolated to a general claim, should not be extrapolated. Okay, about the universe, that's pretty broad. Hold on, I mean, this could be a bit in the right direction, but I'm not sure if the details are correct. So D, it supports a claim about an isolated systems. So text 1, would he say, oh, that experiment supports a claim about an isolated system of atoms in a laboratory? That is the claim, it can't be reversed. The entropy is, it's not reversible. But that the claim should not be extrapolated to a general claim about the universe. Well, yeah, there were some potential issues, so maybe not. I don't know the details here. So this is a possibility, but it supports a claim about an isolated system. I'm not sure you make a claim. Do you make a claim about the isolated system of atoms? So let's be clear. Text 2 says, an experiment which they confirm the irreversible thermodynamic processes producing entropy by applying a rapidly oscillating field of carbon-13 in liquid chloroform. Does it say that's an isolated system of atoms? Not exactly. One can assume. Or it's a laboratory? Probably, but it doesn't say that. But that the claim should not be extrapolated to a general claim about the universe. No, it's not saying it should not be extrapolated. That's not clear either, right? There might be shortcomings in this study, but I don't know as though he would say that should not be extrapolated to a universal claim. I still think B is the better answer. Provides empirical evidence. Text 1 would say that provides empirical evidence of the current understanding of an aspect of physics at a microscopic level. Right? That's a quantum level. When we use microscopic or quantum, here it says quantum, not microscopic. So that might be an issue. With B, must be incomplete. And the aspect would be the reversibility. I still say B is the better answer than D. Okay? D has some two extreme areas. Should not be extrapolated. That's like almost definitely not to the universe. I don't think D is right. B is the better answer.